Hello everyone, this is the video lecture for Pre-Calculus Section 8.3, Complex Polar and de Moivre's, or de Moivre's. Anyways, so what we're going to be learning here is related to vectors back in 9.1 a little bit. Let me go ahead and talk to you about the complex form. So we have my vector v is equal to a comma b, let's say. If you remember from 9.1, I go out some a, I go up some b, and there's my vector out to a point. So this can translate over to a point, I suppose you can say, of z equal to a plus bi. Now, there is a real part. This a right here is your real part. And the b is your imaginary part. Okay, now this is a point. Another way we do x comma y as a vector, it relates over to the point x comma y, which is also related to this x plus yi business, okay? They're all interconnected. They're all interconnected. Now I'm using the, I guess you could say kind of like the vector idea, because we're going to be talking about radius and angle here pretty soon. So this would be your radius, of course, that distance, and this would be your theta. Now, that's, again, relating it to some degree, I guess you could say, degree. But it's all interconnected. So let's start with some examples here. I mean, this is going to be one big section, guys. So here we go. This is interesting. 8.3.010. So I've got z is equal to 2 minus 7i. And I'm going to translate that to 2 comma negative 7. Again, this is an xy point immediately. And I need to graph it. I mean, graphing this is not too hard. 1, 2, 1, 2, 3, 4, 5, 6, 7. About right there. You can call that z if you want. Or you can call it p. I mean, whatever you want. It's just a point out there. Z. What they're wanting also, so that's one of the answers. The other one's going to be my radius. My radius. Which they call the modulus. Or the magnitude. Going again back to chapter 9, which I had explained is kind of like absolute value. Okay, so there's like a lot of overlap yet again of what's going on here. Well, I'm trying to find out r given an x and a y. This is actually very simple. It's Pythagorean theorem. So you might be wondering, why are you going into all this extra stuff if it's just going to be easy like this? This is very easy. There's not a lot of crazy math here. So why do I have to learn about modulus and magnitude again? Why do we talk about vectors again and all that kind of stuff? Well, because it's a holistic concept. So we're going to keep going. As we keep going, you'll be seeing more and more about why we're doing it. So we got z is equal to negative 3 plus 6i. Again, this is x, this is y. Very simple. Not a big deal here. I can translate that into a point xy right now. They are going to ask about z complement, z bar, z complement. I think it's just complement. So negative 3 minus 6i. Notice what happened is that I'm changing the I component. I change the I component, the imaginary component. Only. Okay? That's it. Only the imaginary part gets changed. So the negative 3 stays the same, but that positive 6 is now turned into a negative 6. And they just want to graph both of them. So I have this point, negative 3, comma 6. 2, 3, 4, 5, 6. So there's my z. Well, the other one will be negative 6. 1, 2, 3, 4, 5, 6. Down here. Okay. That's it. So no big deal there. It's actually very simple. I don't even think we talk about the complements too much more. Okay, so moving on. Now that you've kind of seen what the, I guess you could say A plus BI format would be like, and you're kind of familiar with it now, we're going to move on to a new format. So this is very big right here. Huge, big, huge. Very important, okay? And it's very important that you go through every part, every component, every piece, every word that I'm saying here. So I want to write this another way. I already have z is equal to x plus yi. We've just established that. I'm going to rewrite this as r times cosine theta plus I times sine of theta. Okay? Now, this is really cool and all. This is what WebAssign's going to want. So basically, they just say, we'll convert it over. I'm going to go one step further on a very specific purpose. I'm going to say r times cis theta. Now, notice this last one. This is me. This is Chad. Or Professor Burrow, whatever. This is mine. Okay, this is not what WebAssign's going to have, okay? WebAssign is over here. This is WebAssign, okay? So why am I going a step further? Well, I will show you that going this step further is very important, and it makes the math so much faster and easier. It's so much better. I don't know why WebAssign does not take the CIS format. Where's CIS coming from? Notice CIS, cosine I sine. So I'm just simply replacing this right here with a more compact version. I think that sometimes writing it out long-wise, we get lost. We get lost in what's going on here, okay? And I personally don't like it at all. It's just too long. So why don't I just type CIS, move on, you know? Plus the formulas work for this format so much easier. So how are we going to convert from here to here? How are we going from rectangular into this polar format? Well, we just did that a section or two ago. So r is equal to the square root of x squared plus y squared. And of course, theta is equal to the arctan of y over x. Now, that's cool and all. Remember that we might have to add or subtract some pi's or 2 pi's or who knows. So this might have to change a little bit. Anyways, let's do this thing. 83030. So I've got z is equal to 6 minus 6i. And they want to convert it over to the RCIS format. Well, first off, we need an r. So I'm going to do 6 squared plus a negative 6 squared. And this is just x and y. Very simple here, okay? 36 plus 36, square root 72. Okay? Well, that was easy. Let's also do it for the theta. Remember that we got arctan of y over x. Well, that's going to be a negative 1. Basically 45 degrees. This is negative 45 degrees if you go into the calculator. Let's pause for a second here. Is negative 45 degrees good for what we're going to be using here in WebAssign? No, it's not. 2 things. First off, this is a positive x and a negative y. So positive x, negative y, we're actually down here in quadrant 4, which this is good then. Negative 45 is not too bad, but they're going to always want it from 0 to 2 pi, basically within the first revolution to make it positive. So in order to do that, I'm going to add 2 pi to this to make it go around. That's why I don't really like this right here. I like to also add 2 pi or minus 2 pi or whatever else we need to do here to make this thing work. This formula alone is not good enough. It's a format as well. So I'm going to take this guy and add 360 or whatever you want to do. So we had a negative pi over 4, and I'm going to add the 2 pi, and we get 7 pi over 4. That's what we're going to really use. Again, coterminal right here in quadrant 4. So we got our r and our theta. I'm going to give you my answer, and then I'm going to give you their answer. So z, this is the same thing. I'm just converting those over, okay? This is the same thing. Z equals, well, my r cis theta. So square root 72 cis 7 pi over 4. That's it. Now, this is not acceptable to WebAssign, sadly. But what is acceptable to WebAssign is this guy here. Writing it out the long way. And that's okay. We're all going to get through this together. There we go. This is what you have to type. Notice the difference. I mean, look how easy that would be versus this big mess. And yet, they won't accept the one above it. That's okay. I'll get over it one day. Okay, moving on. 83036. Same kind of problem. Z is equal to 6 plus 6 square root of 3i. First off, I want to graph this thing and make sure I'm going to do this right. Notice that we got a positive, positive. So positive 6, and then this other guy is going to be a little bit bigger. So over here somewhere, quadrant 1. So that's good. My r is going to be the square root of 6 squared plus 6 square root of 3 all squared. So 36. And then over here we got 36 times 3 is, well, 36 times 3. That'd be good enough. And so I got 12 out of this guy, by the way. So r equals 12. My theta is going to be the arctan y over x. Y over x. 6's cancel, leaves a square root 3, but again, we already can do this from the unit circle. It's technically, if you want to know, square root 3 over 2 over 1/2. We've done this before as well. Y is the bigger one, x is the smaller one. It essentially ends up being a 60 degrees or pi over 3. And notice that this theta here, pi over 3, is in quadrant 1. And so we're good to go. This is good, everything's good. Let's put it all together now. Z, again, I'm rewriting this. Z is equal to r CIS theta, okay? So then I've got 12 CIS pi over 3, and we're done. That's my answer. That's not their answer. Again, I'm doing this not just for simplicity's sake right here, because honestly, that's not really the point. The point is going to be the formulas here in just a minute. Where it will be more important. Okay, awesome. That's what they want. So, another one, 83048. This one's interesting because it's not exactly simplified to start with. We got this. And they say, go ahead and rewrite it. This is equal to what in polar form or whatever. Well, I'm going to distribute to be able to simplify 6i. Now plus, and then this would be 6i squared. If you remember, 6i, like the I squared is actually equal to -1, straight up. So then I actually have 6i plus 6 times -1. Well, this is just -6. I'm going to rewrite it as -6 plus 6i. Notice that I want to keep it in a plus bi format or x plus yi format. This is cool. I like this. This is going to be what I really start using as I keep going. Notice that x is negative and y is positive. So x is negative, y is positive. We're here in quadrant 2. When I start doing my arctangent, I'm probably going to end up down here. I'm going to add pi to it to make it work. Okay, so that's just a thought before I even keep going. Okay, now we actually have to do the work. So r is equal to, and notice we got 6 and 6. 6 squared plus 6 squared, negative, positive, should just cancel anyways. So we get square root 72, just like last time. My theta, again, is arctan of y over x, and we get it to -1, which makes it the negative pi over 4, the negative 45 degrees, which I already suspected. But I don't want it down here in quadrant 4. I want it quadrant 2, so I'm going to add a pi. Now I'm going to be back up here at 3 pi over 4, and that makes more sense for my theta. So I got my r and my theta. Everything's good. So my z, or my answer, like simplified, this guy right here, should be square root 72 CIS of 3 pi over 4. Of course, they won't take that. And I'm going to rewrite it. I think typing is faster than writing, honestly, at least for me. So maybe that'll be a good thing for you. Okay, so we've converted quite a lot. We've already, gone through it all, Cool, we understand the difference between all the stuff. So why am I still wanting and insisting on this CIS format? It's because of the next formulas, that demoivre stuff, which we haven't done yet. So I have the next problems. These are the next problems. I have a Z1, which is equal to square root of 5 CIS of 5 pi over 4. And then I got a Z2, which is equal to 2 CIS pi. Now, you might be wondering, well, did WebAssign give you CIS? No, I converted it. It was that long version for both of these. I'm just writing it more succinctly. What they're wanting on this problem is they want Z1 times Z2. They want Z1 divided by Z2. Okay, so we need to find both of these guys to keep going. How are you going to multiply these? How are you going to divide them? All right, I mean, what do you do? And so I'm going to tell you that the CIS format is very good about this. I'm going to give you the formulas. So here's some formulas for you. When I multiply them, Z1 times Z2, I'm going to be basically saying this is R1, R2, CIS of theta 1 plus theta 2. Okay? Let me do this one, and then we're going to see the commonalities. So then divided is R1 over R2, CIS, theta 1 minus theta 2. I often am reminded of the log rules. It's not exactly the same at all, but it has a certain flavor to me that is kind of similar, where I had multiply, and now I'm going to have an addition. I have division, and now I'm going to have a subtraction. Yeah. Again, that's not what log rules do. They're different, but it just kind of reminds me of that kind of stuff. Notice that in the front, I'm still actually dividing or multiplying depending on what we're actually doing. So the number numbers in the front do whatever we need to do. But on the inside, these are going to follow what I would say like an operator dimension less. Like we think multiply, right? Well, what's lesser than multiply is addition. Basically addition, multiply, and then power would be the next guy up. Same thing here, I'm dividing. Well, now I'm going to go down a level to subtraction. This is making a smaller number. This is making a smaller number. This is making a bigger number. This is making a bigger number. That kind of idea. Okay. So let's actually do this thing. So Z1 times Z2, I'm then going to say it's the square root of 5 times that 2 right there, CIS of 5 pi over 4 plus pi. Now again, remember that WebAssign, you don't have to simplify. And so that's it. You're done. Oh, why? Why is it not working? Because it's the CIS format still. And they want you to write it out the long ways. Now, you do not need to simplify on the inside. But obviously you could. It would be, what, 9 pi over 4? I would not try to co-terminate those. I would just leave it alone. If they say something like you do... Actually, I'm seeing they do need to co-terminate. Okay, never mind. I'll show you. Try this. Just try this and see what happens. My notes, I have something else. So I'm going to show you what I... This might work. I can't remember. This is for you to discover. But that's fine. What they're going to say is that this guy right here ends up being 9 pi over 4. And they're wanting to go from 0 to 2 pi. So then what do we do now? So 9 pi over 4 is a whole revolution and then 45 degrees. And so basically I'm going to say minus 2 pi. And that yields my pi over 4. And therefore my final answer, writing it out longwise, is this guy here. Okay, this is definitely what WebAssign would give you as the answer. I would suggest playing around and seeing what works. Maybe WebAssign has changed technology-wise and they now accept the CIS format. Maybe. That would be pretty cool. You could tell me if that's the case. I don't know, maybe you're listening to this recording years from now and they finally changed it. I don't know. I'm just telling you what I remember. To divide them, I got the square root 5 over the 2. Again, CIS of my first one, 5 pi over 4, and then minus the pi. And we're done. But again, not really. So I need to simplify this a little bit here. 5 pi over 4 minus the 1, which is 4 pi over 4, so just pi over 4 again. Kind of funny that we got back to the same guy. And to go the long route, again, would be this guy here. Okay, awesome. We got a lot more to go. That's okay. It's okay. It's not hard. It's not hard. I hope you're not seeing that it's not hard. It's just, I guess I get annoyed by little things. I need to give you a new formula. This one's going to want z to the n power. I think this is the official Demoivre's theorem or whatever it is, formula. But here we go. I got r to the n times cis of n times theta. I'm going to put a time sign just so that you're recognizing that we're multiplying here, okay? Okay. If I have something to the n power, I kind of, in a way, I don't know, finger quote, distribute my power. I don't really do that. My r gets it, but then notice on the inside, it's dropped down to a multiply. When I say this, I don't even know what I call it, but it's operation dimensions, maybe. I don't know. So we got power, and then we got multiply, and then we got addition. Notice that all these are like in the positive. They make more, make more, make more. They're bigger, bigger, bigger. On the other side, we would have the division and the subtraction. So what goes here? It's actually roots. Roots go over here. Now, it's not always a square root. It could be the nth root or something, but that's the idea. Let's do this thing. So we have, in this particular case, this problem, 1 minus I to the 10th power. Let's just pause. So, what I want to do in the very end, this is equal to what, and we're trying to simplify. Okay? And they're going to want it in the format of a plus bi. I'm going to go ahead and tell you that right now. This is the format in the end that they want. Could you write this out 10 times and start foiling it? There's 4. There's 5. You get the idea. Could you do this right here and start foiling them and then foiling those and foiling... You see what I mean? You could eventually get down to an answer and put it there. That is possible. I'm not going to do that because the CIS formula that we're going to have here is so much better. So what I need to do in order to make this work is I need to convert this over to RCIS theta to the 10th power. And then I apply this formula, and then I simply just reverse back into the i's. Okay, so again, let's just go back over what we got here. I got 1 minus the I, all to the 10th power. Well, I need to convert this guy in the inside. Notice that's a positive 1 and a negative 1. So I got a positive x and a negative y. We're down here in quadrant 4. Notice that it's going to be a 45-degree angle. And so, just to be straight with you, this would be 7 pi over 4. If you're starting from here, it'd be a 7 pi over 4. So I got my r is equal to, if you can see here, I got 1 plus 1, so 1 squared plus 1 squared. You got a square root of 2, and my r is going to be a 7 pi over 4. Okay? So given that I have these things, I can rewrite this now as square root of 2 CIS of 7 pi over 4, all to the 10th power. So then that 10th power is going to be now pushed into both of these guys. I got the square root of 2 to the 10th power, CIS of 10 times 7 pi over 4. Well, this guy's kind of interesting because this is a half power, 2 to the half power, and then 10 times a half, powers multiply, make 5. So 2 to the 5th is 32, CIS of. And I need to figure out what this angle is. I guess you could say it's like, well, the 4 and the 2 can cancel a little bit, right? I can cancel a 2 from both of these, so it'd be 5 and a 2 there. So what, 35 pi over 2? Now, it's pretty interesting, pi over 2. And again, I'm wanting to convert this guy over. Pi over 2, 35 of them. That's 90 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 35. Basically, we're going straight down. Isn't that weird? And so then I've got now 32 CIS of basically 3 pi over 2 when I convert it down enough. I'm going straight down. What does straight down look like? Well, like what would be a point down here if I had a radius? My R is 32. I'm going 32 straight down. Well, my x comma y point would actually be 0 for x, and my y would be a negative 32. Because again, what does this mean? It means straight down. Like from the origin. This is my answer, but I need to put this into a plus bi format, x plus yi format. So 0 minus 32i. There you go. If that was confusing, I understand. Let's do another one. 83069. So I've got the square root of 2 over 2 plus the square root of 2 over 2i. And they say go to the 16th power. This is kind of interesting because this is your x and y, and this is actually on the unit circle. If it's on the unit circle, do you know something? Your r automatically is a 1. Square root of 2 over 2. Your angle would then be 45 degrees, or again, pi over 4. That's good to know. So I'm going to rewrite this now as 1 CIS pi over 4, all to the 16 power. Again, distribute, I don't know, they both get it, basically. So 1 to the 16th, which is just going to be a 1, CIS of 16 pi over 4. Obviously, that's going to simplify down a little bit. So I got a 1 CIS of 4 pi. I want to know where 4 pi is. So this is 0. This is 2 pi. That's 4 pi. So we're right here. So we're going straight positive x-axis. What's your y value there? Is 0. How much distance am I traveling? 1. That's my radius. So I've got 1 distance, 0 for y. And therefore, when I go back to x plus yi, 1 plus 0i, the answer here is simply a 1. Yep, this whole thing right here is equal to 1. Isn't that funny? It's not funny. It's not funny. 83079. Now we're going to find roots. Check something right quick. This is not the last question. You wish this was the last question. So they say find the 4th roots of negative 256i. Now what do they mean by roots? Formula time. Let me go ahead and give that to you. The nth root of z is, and this is z by the way, is equal to the nth root of r, CIS, of theta over n plus 2 pi k over n. As long as k is 0, 1, 2, 3, all the way to n. That last bit was not very good looking. Is it n or no? It's n minus 1. I'm sorry, n minus 1. Technicalities. So I want to talk about the graphical nature of what roots would look like, and then we can actually understand them. Let's say that I had some kind of angle like this. I don't know. And they say find all the roots for it, the 4th roots. Well, 4th roots are going to cut this thing up into 4 pieces. So 4th roots are going to give you 4 answers. Cube root would be 3 answers. And they're all equidistant. So you find your first one, wherever that is. I don't know exactly where that is. But then after that, They're all going to be equidistant from it. That's this guy right here. He's creating more answers by just simply starting at a place and going from there. So how do we make this thing work? Well, my z original here is 0 minus the 256i, negative 256i. This is my x, this is my y. Cool. So then I want to convert this over into CIS form. My r should be obvious that it's a 256, basically 0 plus this and absolute value and all that kind of stuff. If you draw this thing, I got 0 for x, but negative y, so it goes straight down, 3 pi over 2, straight down. So then I can rewrite this z as saying 256 CIS of 3 pi over 2. Okay, so this is my new z. And they're wanting to do the fourth roots of that. Okay, I guess in a way they're kind of saying the 256 CIS 3 pi over 2, and then this is the fourth roots of that. Okay, so then how does that work? Well, I'm going to have the fourth root of the 256 CIS of, and then this is where it gets a little tricky, okay? I'm wanting to now divide by 4. So 3 pi over 2 divided by 4, and then I'm going to be adding that 2 pi k divided by 4, okay? Well, the fourth root of 256 is actually just 4. You can go to the calculator for that guy. And this guy here simplifies a little bit to 3 pi over 8. And then we're going to have some more stuff, okay? So like plus something or other, blah, blah, blah. I don't want to go too far on that right now. I just want to make a point that we're starting at 3 pi over 8. And where's 3 pi over 8? Well, this is 4 pi over 8. So 3 pi over 8 is probably about right there. So my answers would then be, that look something kind of like this. Again, we got 1, 2, 3, and 4 equal opposite angles. So I'm just cutting them into 4. Notice that I'm going to have a 90 degrees between each one of these because I'm going to have 4 of them. That is the easiest way to see that. But to give you the answers, I'm going to just go and actually plug in 1, 2, 3, 4 or whatever I need to do. I think it's 0 as well. 4 CIS 3 pi over 8 plus 0. 4 CIS 3 pi over 8 plus, and then 90 degrees, basically. But what's going on is it's 2 pi k, k is now 1, divided by 8. Notice that you're going to have that, is it 8? No, 4, I'm sorry, not, I was seeing the 8 right there, it's a 4. Originally, it's a 4, right? Fourth root, 4. So that's a pi over 2 business. Well, then you're done there. 3 pi over 8, and then plus 2 pi times 2 all over 4. And we got one last answer, CIS, 3 pi over 8 plus 2 pi times 3 over 4. Now, again, these just basically equate to 90 degrees, 180 degrees, and 270 degrees in this particular case. Not every case. Put a comma between them, put it all in the box, type it all out, and there you go. You're wrong. Oh, why? Because it's still CIS format, and they want the long version for every single one of them. And now I hope that you can see why I'm annoyed by this. Because it's a very simple thing to type CIS. Not so fun when you've got to type cosine I sine with all the angles twice. Don't simplify it. You give them too much credit. Don't simplify it. Purposely don't simplify it just for their sake. Make them do the work there. You've done enough work. On the next problem, we're going to do this again. On the next problem, I am not going to write it out the long way. It just is far too long when we've done this a million times. And by the time you've gotten to this problem on the homework, you're a typing master. That's right. That's what this is. You're doing typing skills. They are not only teaching you calculus, they are teaching you how to type calculus. And I am being taught how to write calculus because often I'm the one that types. Okay, my hand hurts. There you go. Um, that lecture experience that you've always wanted here online pre-calculus. All right. Here we go. I got last question. Z to the 8th minus I is equal to 0. Solve for Z. Who thinks this stuff up, right? What's going on here? Well, I need to get Z by itself. Move the I over, I guess. Seems innocent enough, right? Right? Now it's a positive I. And then I'm going to 8th root both sides. Ignore that plus and minus. At least I hope so, because otherwise it'd be way, way, way bad. And I don't like just I. Just I is kind of boring. It's 0 plus 1I. Notice that I'm trying to create my x's and my y's so that you can see them. X is 0, y is 1. It's actually straight up. And so my r is equal to 1 when you do the math. And theta is equal to pi over 2. Straight up. Like up. It's going up. And the 8th root of that. So what I'm saying is the 8th root of, and then I got my 1 CIS pi over 2. And I need to rewrite this. So then I got the 8th root of the 1 CIS of pi over 2 divided by the 8, and then plus that 2 pi k divided by 8. Well, 1 to the 8th root is still a 1 CIS of this guy here is now a pi over 16, and we're going to have more stuff. I'm not too concerned right there yet. What I'm saying is that right now I've started at pi over 16, just kind of tiny, very tiny, 1 radius. I need 8 equal pieces for this. Think of like a big pizza. Oh man, if I could draw a circle today. Think of a big pizza, and I'm cutting it up into 8 slices. It's a fairly common amount of slices. That's good enough. So how would you cut 8 slices into a pizza? How would you, human, cut this into 8 slices, knowing that this is the first slice? They already got the first slice. How would you do more? Well, I would go and cut this guy over here and then make 90 degrees. Humans are really good at 90 degrees. And then I cut this in half right here. Do you understand? That's how I would draw it. Anyways, each one of these here is, if you can tell, I got 8 of them. So those are going to be a pi over 4 each. And you can see that from right here. See how that's going to end up being a pi over 4? Or again, 45 degrees. Everyone gets a 45 degrees. So let me go ahead and list out the answers. And sadly, you still need to do the cosine I sine answers. But I'm just going to write out the CIS because I'm tired of writing them. Just straight up between you and me, I'm over it now. I mean, it's a good math. I love the math here in this section, but it's just WebAssign is limited here, and that's kind of sad. Normally WebAssign's pretty darn good. I've had a great experience with this program in the past, and still do. But there are a few picky moments that make you want to cringe. Again, don't simplify. Why simplify? Why would you put yourself through that? Just if you're already typing this much, and this isn't, remember, it's cosine I sine you have to write. If you're already typing this much into one box, why torture yourself by even doing more math when you should let them do it for you? 8 answers that go in this one little box. I've also seen that the box gets too big, and like here, this is a perfect example. I have my box, right? And I start writing, and it's like, what am I typing now? I don't know what to say. It's just problems, big problems. So just put that in as best you can. Oh, you know what? I think they actually have 8 boxes. There's got to be some relief to this thing, okay? Something. Anyways, there you go. Type it out the long ways. And that's all I got for right now. So if you have questions, of course, let me know. I'm doing the best I can. WebAssign's doing something. So anyways, thank you very much. Have a great day.